Hello students, welcome to today's lesson on molar mass and how to calculate moles. So before we begin, let's recap what is molar mass. So molar mass is the mass of one molecule or compound. So how do we calculate molar mass? First, we need to understand what is relative atomic mass. So relative atomic mass of an atom is the average mass of one atom of that element compared to 1/12 of the mass of one carbon-12 atom. So basically it means what is the mass of one atom. So to find out what's the relative atomic mass, we can look at the periodic table. In this periodic table that we look at, the relative atomic mass can be found at the bottom of the element. So for example, this hydrogen atom, we can see the relative atomic mass is 1. So the mass of one hydrogen atom is actually 1 gram. Now we go through some example on how to calculate molar mass. So first example, over here we have chlorine, which is Cl2. So the number of atoms here is 2 times chlorine atoms. So it's 2 times, so the relative atomic mass of chlorine is 35.5. So with 2 times 35.5, you end up with 71 gram. So next we have oxygen. So it's 2 times oxygen atoms. So it's 2 times oxygen is 16. So it's 2 times 16. So you get 32 gram. So for water, we have 2 times hydrogen atoms and then 1 times oxygen atom. So it's 2 times 1 and then 1 times 16. So we add them all up. This is 2. So it's 2 plus 16. We'll get 18 gram. Next we have this compound, sodium chloride. So it's 1 times sodium and then 1 times chlorine. So for sodium is 1 times 23. So we end up with 23. So for chlorine is 1 times 35.5. We end up with 35.5. So we add them all up. It's 23 plus 35.5. We'll end up with 58.5. So next we look at ethanol. Ethanol is 2 times carbon and then 6 times hydrogen. Take note here, there is 5 hydrogen atoms here and 1 at the back. So total of 6 hydrogen atoms and 1 times oxygen. So 2 times carbon is 12. So 2 times 12, you get 24. And then we have 6 times 1, you get 6. And then 1 times 16, you get 16. So we add them all up, it will be 24 plus 6 plus 16, you'll get 46 gram. So this is how you actually calculate molar mass. So next, we move on to how to calculate moles. So to calculate moles, there are 4 ways to do so. First, we actually look at the number of particles of the atoms. Second, we look at the mass in gram. Third, we look at volume of gas. And fourth, we look at concentration in mole per dm cube. So we'll go through each method and the formula to actually calculate the number of moles. So first, we have for a number of particles. So for 1 mole of any substance, it will contain 6 times 10 to the power 23 particles or atoms. So this is also known as the Avogadro's constant. So to calculate the number of moles, first we take the number of particles or atoms divided by the Avogadro's constant. Next, to calculate the number of moles using mass, the number of moles can be determined by taking the mass of the element or compound divided by the molar mass, which we learned how to calculate earlier. Next, we look at how to calculate number of moles of gas. So we take the volume of gas in dm cube or cm cube at room temperature or and pressure. So if you are taking the volume of gas in dm cube, you divide it by 24 dm cube. And if you're taking the volume of gas in cm cube, you divide it by 24,000 cm cube. The reason is 1 dm cube is equals to 1,000 cm cube. Now let's now move on to concentration in mole per dm cube. So the formula for concentration is the number of moles of solute divided by the volume of solution in dm cube. So we'll go through the example on how to derive the number of moles for concentration. So first example, let's look at this. So the number of moles of iron, with 3 times 10 to the power 23, atoms. So the number of moles here, is equals to the number of atoms divided by the Avogadro's constant Okay, so we'll get 3 times 10 to the power of 23 divided by 6 times 10 to the power of 23. So we cancel and cancel. We'll get half over here, 0.5 mole. Okay, so now let's go on to the second example. So what is the mass of 1.204 times 10 to the power of 22 atoms of lead? So first, to do so, okay, we need to determine what is the number of moles. So the number of moles is equals to, okay, the number of particles or atoms divided by Avogadro's constant. So in this case, it's 1.204 times 10 to the power of 22 divided by 6 times 10 to the power of 23. So in this case, we'll get 0.02 mole. So to calculate the mass, so mass of lead, which is PV, okay, will be, we take the number of moles times the AR of lead. So it's 0.02 times 207. So we'll get 4.14 gram. Okay, so now let us continue. So the next example is, how many moles are there in 20 gram of magnesium oxide? So for magnesium oxide, first we need to determine what's the chemical formula. So magnesium oxide is MgO. So we need to find out what's the molar mass of MgO. So it will be 1 times 24 plus 1 times 16. So we'll get 40 gram. So to determine the number of moles of MgO, it will be the mass, which is 20 gram, divided by 40, which is the molar mass. You will get half. Okay, so it will be 0.5 mole. Okay, so now the next example will be, how many moles are there in 6 dm³ oxygen gas? So the number of moles, okay, of O2 gas is equals to, okay, volume of gas divided by 24 dm³ in this case. So it is 6 dm³ divided by 24 dm³. So we'll get 1/4, which is 0.25 mole. Okay, so the last example here, we'll look at, okay, the concentration. So how do we look at, first of all, we need to recap on what's the formula for concentration. Okay, so the number of moles of sodium hydroxide present in 25 cm³ of sodium hydroxide solution with a concentration of 0.2 mole per dm³. So concentration, okay, is equals to, okay, the number of moles of solute divided by volume of solution. So if we rearrange the formula, we'll know that the number of moles here is equals to the concentration times, okay, volume of solution. Okay, so in this case, the concentration is actually 0.2 mole per dm³. So 0.2 mole per dm³ times the volume of solution, here is 25 cm³. So 25 cm³ of sodium hydroxide. So we need to change it to dm³. So for 25 cm³, we need to divide it by 1000. So in this case, we'll get 0.005 mole. So the number of moles of sodium hydroxide present in 25 cm³ of NaOH solution, okay, will be 0.005 mole. So that's all for today's lesson. Hope you learned something. Thank you.